We all use mathematics every day. Mathematics is the study of numbers and shapes. We use numbers whenever we count or measure things or tell the time. But before we start, let me ask you first, for you, what is mathematics? So mathematics is the study of patterns and structures. Mathematics is a fundamental to physical and biological sciences, engineering and information technology, to economics, and increasingly to the social sciences. Mathematics is a useful way to think about nature and our world. And lastly, mathematics is a tool to quantify, organize, and control our world and predict phenomena and make life easier for us. Where is mathematics? Many patterns and occurrences exist in nature, in our world, in our life. Mathematics helps make sense of these patterns and occurrences. What role does mathematics play in our world? So first, mathematics helps organize patterns and irregularities in our world. Second, mathematics helps predict the behavior of nature and phenomena in our world. And third, mathematics helps control nature and occurrences in the world for our own ends. And lastly, mathematics has numerous applications in the world, making it indispensable. So let's begin with the patterns and numbers in nature and the world. Patterns in nature are visible regularities in form found in the natural world, can also be seen in the universe. Nature patterns, which are just to be admired, they are vital clues to the rules that govern natural processes. Patterns can be observed even in stars which move in circles across the sky each day. The weather season cycle each year. All snowflakes contain sixfold symmetry, which no two are exactly the same. So let's jump to types of patterns in nature. Symmetry indicates that you can draw an imaginary line across an object and the resulting parts are mirror image of each other. There are two types of symmetry. First, the reflective, and second, the rotational symmetry. So let's begin with the reflective symmetry. So reflective symmetry means that one half of an image is the mirror image of the other half. It also sometimes referred to as line or bilateral symmetry. While the rotational symmetry means that the object or image can be turned around a center point and make itself some numbers of times. Included in this type are threefold symmetry, fourfold symmetry, fivefold symmetry, and sixfold symmetry. Tessellations. Tessellations are patterns formed by repeating tiles all over a flat surface. The arrays of hexagonal cells in honeycomb or the diamond shape in a pineapple are natural examples of tessellation patterns. So next is the Fibonacci sequence. So it is one of the most famous and perhaps the most interesting number patterns in mathematics. Other than nature, numerous examples of Fibonacci sequence as well as its derivative, the golden ratio, can be found in art, a stock market, and other areas of society and culture. So Fibonacci sequence is a set of numbers that starts with a 1 or a 0, so followed by 1 and proceed based on the rule that each number called a Fibonacci number, so which is equal to the sum of the preceding two numbers. So the Fibonacci sequence is named for Leonardo of Pisa or Leonardo Pisano, so an Italian mathematician. So Fibonacci used the arithmetic series to illustrate a problem based on a pair of breeding rabbits. So breeding rabbits are one of the most sample for Fibonacci sequence. So the Fibonacci sequence is related to the golden ratio, a proportion that occurs frequently throughout the natural world, and it is applied across many areas of human endeavor. So guys, let's continue on how mathematics helps organize pattern. So based from Fabrizio 2018, mathematics has helped organize patterns and consistencies in the world because One must know that there is always mathematics in almost everything in the world. An example is an arrangement or grouping that repeats. Many things in our universe is pretty predictable. Asking the right questions, hold the answers, and gaining knowledge by finding an explanation and testing if you're right or wrong. So guys, I know some of you asking yourselves how mathematics helps predict phenomena in the world. So we're gonna answer that question. So mathematics helps predict our phenomena in the world. So what you can see today in the modern world, which all appear to be controlled by rules of mathematics, the culmination of lots of experimentation, observation and error correction, which by the way is still going on. This all works because mathematics gets to the underlying essence of each phenomena. Mathematics helps control nature and occurrences in the world for our own good. How does mathematics helps control nature and occurrences in the world for our own ends? So let's answer it and know how it controls our nature and occurrences in the world for our own ends. So it is interesting then to ponder on how mathematics, an invention of the human mind, seem to permeate the natural laws that hold the universe together. There have been instances when a natural phenomenon has been speculated to exist because mathematics says so, but no hard evidence had been found to support its existence, such as phenomena were proven to exist or only when an advancement in technology has allowed us to expand our horizons. So here we go. This will be the last. Mathematics plays an integral part in our daily living because everything we see, touch and feel, you can't hide the fact that there is a map involved. So mathematics is helpful especially when seeking to explain the limits feeling one gets when contemplating the natural world that exists outside ours. Mathematics can surely foretell the behavior and phenomena in the world, uses actual state of measure to help us eye the length of all things. When you learn mathematics at once, our common sense can apply our own predictions to the phenomena we occur.
Mathematical language and symbol. Characteristics of mathematical language: precise, concise, and powerful. Expressions versus sentences. Conventions in the mathematical language. 4 basic concepts: sets, functions, relations, and binary operations. Elementary logic. Connectives, quantifiers, negations, and variables. Formality. Problem solving and reasoning. Inductive and deductive reasoning. Intuition, proof, and certainty. Folia's 4 steps in problem solving. Problem solving strategies. Mathematical problems involving patterns. Recreational problems using mathematics. Data management. Data gathering and organizing data. Representing data using graphs and charts, interpreting organized data. Measures of central tendency, mean, median, mode, weighted mean. Measures of dispersion, range, standard, deviation, and variance. Measures of relative position, z-scores, percentiles, quartiles, and box and whiskers plots. Probabilities and normal distributions, linear regression and correlation, least squares line, linear correlation coefficient.